Hello, everyone. We're going to be talking about oceans. We're going to talk about the ocean currents, a little bit of things that we learned about the tides, but we're also going to learn about just a little bit of ocean life. Our standard is EEN 231. Explain how the density of ocean water is affected by temperature and how this results in major ocean currents, distributing heat away from the equator towards the poles. So, we should know that 71% of the Earth's surface is covered by water. Now, how much is ocean water? When we talked about fresh water, we understood that it was only 3% that would be fresh. So the 97 is ocean. So now oceanographers are the scientists who study the oceans and what it processes. Oceans are very important. Without the oceans, we wouldn't even be here. It has a value to our lives. Oceans affect all living things, even those far from shore. As well as we know that the ocean is a house and a habitat for many, many organisms. So, a question. How were the oceans really formed? Just think about it. How was the ocean really formed? And then, of course, we just got land over here, and then we got all this body of water. So what happened? So according to science, when Earth was still young, of course, they said this Earth used to be a whole planet of volcanoes. They said as it erupted, the lava and ashes and gases released from deep within the Earth. But one of the gases that was released is what they call was water vapor. So the water vapor pretty much supposedly cooled enough and formed clouds. Again, clouds is nothing but water vapor held. And so it began to rain. And what they're trying to say is that it rained so much the whole earth was then covered by water. And I know some of you are like, that doesn't make sense. Hey, it's science. I'm going to teach it to you. But again, if you don't believe me, that's fine. But I just want you to pass this test. Okay? So that's how all the oceans and stuff formed, because it got so much water vapor and all these clouds, and it just rained and rained and rained for a long time, and all this water just decided to stay. Now, we should know what our oceans are. Y'all learned this back in elementary school. We have the Atlantic, Pacific, the Indian, and Arctic Ocean. But how many of y'all knew the Pacific Ocean was the largest ocean? Yes, the Pacific. The area and volume of the Pacific Ocean is greater than the Atlantic and the Indian combined. That's crazy. Now, seas. A sea is one of the largest bodies of salt water, less than an ocean, found on the Earth's surface. So we have a few seas. We have the Mediterranean, we have the Arctic, and we have the Black Sea, which are part of the Atlantic Ocean. Now, what about the ocean do we really need to know? The ocean is actually a mixture of gases and solids dissolved in pure water. What they believe is that the earth has all the natural elements inside of the ocean. When we drill for oil and all those things, we find the best stuff in the middle of the ocean. So almost 85 to 90% of the natural elements and the resources that we need have been found in the ocean. So the ocean is a wonderful and mysterious and majestic place. Now, 96% is pure water, but it also has chlorine and sodium. Now, when we mix it up, it's called sodium chloride, NaCl. That is table salt. So that's why the oceans are salt water. So, what about salt water? Well, we call that salinity. So, salinity describes the amount of dissolved salt in the ocean. And we do that per 1,000. So every time we get the numbers, we do that per 1,000. So salinity, the amount of salt inside the ocean. Well, salinity almost looked like the word salt to me. As I mentioned earlier, there's some gases that are in the ocean. Well, nitrogen, carbon dioxide, and oxygen. We all realize that when we breathe out it's carbon dioxide, and we need to take in oxygen, and then when we use the bathroom we release nitrogen. Well, the same thing in the ocean. Oxygen, carbon dioxide, nitrogen, they're there because not only the animals and the organisms that live there, but again, the ocean is very diverse and it's more abundant. All these things are more abundant at the ocean surface because that's where the sunlight hits, and it also causes the plants to be there. So the plants is giving off the carbon dioxide, and we got they take it in the carbon dioxide, and then we have the animals taking in the oxygen, and of course when they use the bathroom it's releasing the nitrogen. So everything in this world is nothing but cycles. So we talked about salinity. We talked about it had gases. Now what about the temperature? Warm water holds less dissolved gas than cold water. When ocean water is cold, it sinks and carries oxygen-rich water to ocean depths. As a result, fish and other animals can live in deep parts of the ocean. Now, I already told you before, I've been to the beach and I feel like it's the water only 30 degrees. But that's good because it means the oxygen levels are high in the water, and that allows those animals to live and not die. So that's when you start having a lot of loaves of fish and everything that's there because that oxygen level is high. But now we also got to talk about the climates. The specific heat capacity, amount of the heat required to change a substance temperature by 1 degree Celsius. Now we talked about this before about water, but water has a high specific heat capacity than air. Water is more resistant to changing temperature. If you keep water in a bottle and you leave it on your dresser, it's going to stay room temperature for a long, long time. It takes a while for it to get cold, and it takes a little while for it to warm up. The temperatures we are experiencing due to the amount of heating of the atmosphere above us and the ground and water around us. So our temperatures we experience has to go what's not only above us, but the water too in the ground that's around us. So we talked about it before, but land heats and cools more rapidly than water. Land also reaches higher and lower temperatures than water. The temperature of land and water influences the temperature of the air above it. So when these two collide, it changes if we're going to have a warm front or a cold front. This explains why inland areas experience greater temperatures than the cities near large bodies of water. If you're around the beach, it's usually around the same temperature. But where we at, we have bipolar weather. One day it's 90. One day it's 70. Next day it's negative 24. The next day it's 112. That is because of the ground and the water, everything is having a different temperature, and then when it hits or collides, it can just discombobulate things. Now, one thing about water that we always know, it has waves. So when you go to the beach, what is the first thing you notice? It's windy. I ain't never been to the beach and ain't never felt not one thing of wind. No, it's always windy. It's always going to be windy by the ocean because ocean waves is caused by wind. A wave is just basically, when we look at the water, it's just visible evidence of that energy is passing through water at that time. What do a lot of people do when they see waves, especially in Cali, in Florida? They surf. So again, a wave in water is a rhythmic movement that carries energy through water. Waves are caused by high winds blowing on top of the water. So if you look here, we have the troughs is going to be what goes down. Remember, we already talked about wavelengths, but this is the wavelength from one crest to the next crest. The wave height is here. It goes from where it is settled to the height of where it gets to. Tides. Throughout the day, the water level at the ocean edges changes. This is what we call the rise and fall in sea level, and that's a tide. You know, we have high tides and we have low tides. One thing we learned about tides are created by the gravitational attraction of the earth and sun. So again, gravitational attraction. This is something we learned about. Tides are created, again, gravitational attraction. And don't judge my pen marks. So, as the moon goes around the earth, and then how the earth rotates on its axis, it depends how, when the water is closer to the moon, we should understand about the tides, and there's a type of effect that we want to talk about. So surface currents. Surface currents are movements of water that flow horizontally, horizon, this way, okay, on the surface of the ocean. Like waves, the energy that drives the surface ocean's currents comes from wind. Our currents come from wind. Friction is also involved in development of surface currents. Now I want you to look at this map. Look at this map. What do you notice about the current pattern in the northern hemisphere? If you don't know, northern hemisphere, we go up. So that's the top, okay? Now look at the arrows. As you see, it moves just like a clock. So that's clockwise. Alright, it says, so what do you notice about the current pattern in the southern hemisphere? That's below. So again, this is clockwise. Now this is the southern, and the arrows are going like this. That is called counterclockwise. So because of the Earth's rotation, currents are deflected to the right. Okay. Then to the left for the southern hemisphere. 30 degrees latitude. But this, you should know, this is a review, the Coriolis effect. So basically, the whole bottom line is this effect causes the surface oceans currents to be deflected. So the movement of water, you need to know this, okay? Upwelling is the upward movement of cold water from the ocean depths. Upwelling brings up tiny organisms, minerals, and other stuff from the deeper layers of water, so all the way from here to the surface of the ocean. Without this, we would have a nutrient deficit. Now here we're going to look at the deep ocean currents. So now we looked at the difference between the northern hemisphere and then the southern hemisphere, but in which direction do warm currents flow? Alright, so obviously north, south, east, west. Well, we look at the warm, and the warm is obviously going this way, so that is west. What about cold? Cold goes east. So the deep ocean currents that move towards the poles are warm. If it goes to the equator, it's cold. Just think the backwards, because we're so used to knowing anything that goes to the equator is going to be hot, but in the currents, for the deep ocean currents, anything that goes to the equator is cold. So your question would be like, why is the water moving towards the equator cold, or why does it become cold? Well, it becomes cold when the current moves deeper underwater. Colder water is denser. Key word, denser. So the warm water, what happens? Obviously, it's not as dense. So it has to bring it back up to the surface. And then when it gets to the surface, it has to have exposure to the sun. Well, if you're in the sun, you get hotter. Now, you probably heard about this, but this is going to be a quick little review. El Nino is an abnormal climate, and it happens every 2 to 7 years on the Pacific Ocean. Okay, this causes changes in winds, currents, and weather patterns. It's not all about just global warming, but this is something that happens between every 2 to 7 years. So yes, this happens against the Pacific Ocean. What happens is it interrupts the pattern of upwelling. So without nutrients provided by upwelling, fish and other ones cannot find food. So that means some of the animals underwater begin to die. And then the weather on the ocean and stuff is a little bit different, and the weather patterns change. So now this is just going back to a review, but the ocean floor, remember we talked about how mountains and stuff were formed. Well, the ocean has what we called underwater mountains, deeper canyons, and large flat plains as well. Remember earthquakes? The rocks are different and the crust is thin. So one thing you gotta know, and this is a vocabulary word, is the continental shelf. It is gradually sloping into the continent that extends under the ocean. So the ocean covers about, the continental shelf is about 350 meters. Large mineral oil, natural gas, or deposits are found there. So this is where we go drilling and mining and stuff as well. It extends from the outer edge of the continental shelf down to the ocean floor is the continental slope. So as you see here, here's the shelf. Now this is usually where we are at when we at the beach. Okay, and y'all just be sitting up here just on the water. But if you go too far out, you have a slope. Some of them is like this. Sometimes some slopes are like this. Some of it is more gradual. So then we have to know about abyssal plains. These are large flat areas inside the ocean. They are larger in the Atlantic and Indian Ocean than Pacific because due to the large deposition of sediments by large rivers. The Pacific Ocean has cracks that trap sediments that gives us smaller ones. These are actually close to the continent and are made of mud and silt. They have tiny organisms that form ooze. The life right here is not abundant in the abyssal plains. So we also have seamounts, which are underwater volcanic mountains. Okay, most of those in the Pacific Ocean. Guyats are the flat top seamounts. So we talked about trenches and stuff before, but you see Mount Everest is one of the tallest mountains, and we can get trenches just as deep as here, as you see. And that's what this one is. The Mariana Trench in the Pacific Ocean goes up to 1,100 meters. That's known as the Challenger Deep. Definitely stay away from that. But these are, again, deepest part of the oceans. We talked about mid-ocean ridges before. This is the area in the ocean basin where new ocean floors form. So remember that once it spreads, and that land will come in between, okay? So in the Atlantic, it's called the Mid-Atlantic Ridge. In the Pacific, it's called the Pacific Antarctica Ridge. So just one thing you want to know is that ocean life zones. The plants and animal life are very, 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 very diverse. We do know that sunlight penetrates the ocean, and of course, temperature is a factor of different organisms in the water. And then the water pressure is also one of the factors of life underwater. So, of course, we have three major groups: plankton, nekton, and benthos. Plankton float near the surface where sunlight can penetrate. Now you all familiar with plankton from SpongeBob. That is truly him. He is really a plankton. Okay. These organisms drift with currents or tides. Plankton are made food for the bigger things, so they kind of eat off of them. But you have zooplankton, which is more like animal-like, and you have phytoplankton. Again, the prefix and suffix to let you know what type it is. So plankton, we have jellyfish, which float on the ocean surface as an example of a plankton, but not really in the category when you go into domains and kingdoms and stuff. So the classification, in just this slide we will understand this, but in biology we'll tell you the actual classification of a jellyfish. This right here is nekton. Well, these are your whales, seals, dolphins, squids. These are a lot bigger and they feed off of plankton and other little fishies as well. They can pretty much go a little bit deeper. They don't have to have. They can have great pressure. They don't also need any light either. This colored fish is also known as a nekton. Benthos is your crabs and lobsters. Deep bottom environments. Some live on the ocean floor and where sun, in the shallow waters though, where sun can penetrate. And a starfish is a benthos. But this is all of our notes. So again, please make sure you review every slide and pay attention to it because you will have a quiz. Everything will be can be direct quotes. And it can be marked wrong if you do not use the exact direct quote. So make sure you review this and pause it, rewind, and stay safe. Coronavirus!